Hello everyone. Welcome to the third part of FME series. It is failure modes and effect analysis. And in first two videos, we have seen the failure modes and the FMEA worksheet, and we prepared the failure modes for sliding door system. We will continue the worksheet and perform FMEA on this automatic sliding door system in this video. So in the previous video, we have prepared this blue part of the FMEA worksheet and we have compiled the failure modes related to each component or function, their root cause, and the impact. Now, in this video, we will use the second part of the FMEA worksheet. That's this allocation of SFD and RPN to the failure modes, the implementation of corrective measures, and the SFD and RPN after the corrective measures have been implemented. So let us check the orange part for each of the failures that we have already prepared. So this is the failure modes which we compiled in our PowerPoint session. I have written them down in the Excel and based on the basic definition of severity, occurrence, and detection, I have assigned some of ratings to these failure modes. So basically, in cases where the collision or some safety related uh, potential effect is possible, so it is assigned as 9 in this lecture so that we can highlight the safety related issue. And if something is cannot be detected, it is again assigned the detection scale of 9. So an occurrence is since these kind of failures are less likely to happen, so the occurrence has been assigned as 3. So the RPN without any design improvement, for example, in this case is 243. That comes from 9 into 9 into 3. Similarly, for this object detection logic not working correctly and false detection, this has been given as 3, 3, and 9 because 3 because there is no uh, collision as such, and the doors will keep on opening without any hindrance. So that is given at 81, that is 9 into 3 into 3. Similarly, for obstacle detection sensor, both these failure modes have been given the same ratings as the impact and failure are same. And the RPN becomes 243 and 81 for them. Next, for motor, controller, and pulley belt, these are the failures which we have tabulated. And impact is same, that is door not opening or closing. So since the impact is same, the severity remains same, that one can collide or there can be some safety related issues. So it is given as 9. And since these cannot be detected by the system in our present design, so it is given 9, that it will go undetected. And occurrence is less because these kind of failures are less likely to occur. And the RPN is calculated in the same way, that is severity into occurrence into detection. Now, we can see that the scale or the rating which we have given to severity and detection are mostly high in all these cases. So we would not like to implement this system as it is. And there should be some countermeasure to reduce the severity and the detection of these failures. So if we try to implement some countermeasure, then for the first case where the sensor is failed and door is not opening and collision is possible, I think there should be logic or the software program to detect the short circuit and open circuit of the sensor. And in case when the failure is detected, we need to open the doors. That is, if we know that the sensor is failed and it cannot detect the people coming around, so we should keep the door open. We should not keep the door closed so that there is no issue to the users. And also, since we have already detected that there is an issue in the system and it should be serviced, we will add two lights. One will be green and red Green will indicate the normal operation and red will indicate the faults. So after implementing this countermeasure, we can see that the collision won't be possible because we will open the gates when there is a failure. Severity is reduced. And since we have already implemented a logic to detect the short circuit and open circuit, the detection is also now possible. And the detection has now become possible. And so the modified SOND are these, and the modified RPN is this. So we can see that after implementing this countermeasure, the possible cases of collision and door not opening will are now reduced, and the RPN has RPN the same is being indicated in the RPN as well. Similarly, for this opening and uh, logic not working for this false detection or the object not detected, uh, we can have the validation of logic for different test cases during the development so that the occurrence is reduced. However, the detection is again not possible in case something happens during the working of the system in after market. So has kept as 9. But since we have reduced the occurrence, the RPN has reduced significantly. Now, for next two failure modes, the countermeasure remains same as the first two implementations, as the fault and root cause are same. So the SOND for these will also get reduced and RPM is reduced. Moving to next, that is a motor not working, a motor not able to run. So in this case, for example, our controller has given the command for to the motor to operate, but the motor is not opening the door. So at present, we do not have any mechanism to detect whether the motor has opened the door or not. So as a countermeasure, we should have a switch to confirm the state of the door, and we should get the states via the switches and confirm that whether the door at present is open or closed. In case there is any mismatch, like if we expect that the door should be open but it is closed, we will indicate that there is a failure via that red light which we have used here as a countermeasure. So here again, uh, since the door won't be operable via motor, so we will provide a mechanical system as well. For example, if the door cannot be opened automatically, the user can use this mechanical mechanism to open the door when needed. So this severity of door not being opened and collision such things will get reduced as it can be opened mechanically. And the detection again will be reduced to 1 since we have already implemented the switches. So for this case also the RPN has reduced significantly and the severity and detection has improved. Similarly, for software bug or error during runtime, the testing of controller should be performed during the development. And in case the internal failure is detected by the software, again the same mechanism, like the fault state should be raised and mechanical lock should be used to open the door. So in this case also, this will become 6, 2, and 1, similar to these, and RPN will get reduced. And for the last one, for fully not able to rotate, we have this point same as point number 5, and this will become 6, 2, and 1, and the RPN is 12. So this is how we have implemented the countermeasures to bring down the severity of the failures. And we can say that after these implementations, our system is relatively safe and reliable than the previous one. So let us summarize the action points or the recommended actions of the FMEA. First point that we saw was to prepare logic to detect the short circuit of sensors. That should be set in the controller itself. And then when the fault is detected, the door should be opened and it should be kept open till the failure is there. So this will again be a logic change in software. And the third is to add indicator lights of green and red to the system and uh, use them to indicate the failure and normal condition. So you can see this in the diagram here that has been added as 5 and 6 element. And next is the validation testing of controller logics and hardware. This will be done during the development phase. Next is to add a switch to detect the actual state of the door and match it with the expected state. And this has become the seventh and eighth element of our system. You can see in the diagram 7 and 8, the switch to detect the actual state of the door. And if there is any mismatch, again the fault will be generated and the door will be kept open. Next is to provide a mechanical system to open and close the door during the failures. You can see the ninth system. It is just an illustration to have a mechanical system to open the door when needed. So basically, we, after performing the FME, has made a robust system and which has included a set of components which were not earlier. And these are basically to improve the reliability and safety of the system. So in blue color, you can see that these are the components which have been added or became a part of the system. Earlier, our system were having four components: sensor to detect the object, sensor to detect any obstacle in the path, a motor, and the controller. Next, these light indicators have been added, the switches have been added, and the manual handle has been added. So to summarize, this on the left side is our raw design, which we were initially thinking, and we performed FMEA and we got the design which is on the right hand side. So if we compare the initial and the final design, our initial design was less reliable and it has less tolerance toward the fault and it needed more time to repair or be diagnosed after the market. But since we performed FMEA and we identified the potential faults and the loopholes in this present system, and after implementing this countermeasure, we got the system at the right. The system at the right is basically more reliable than the raw design. It has better tolerance towards the fault, and maybe the repair time after it is sold is will be less. So this is an example how FMEA helps us to improve our system and why it is performed. So I hope it was easy to understand. And in case you have any doubt, you can comment. Yeah. Thank you for watching.